So good morning, everyone. So good day to all of you. Today, we're going to have our second lecture in General Physics 1. So to continue our discussion on the introductory topics in physics, we are going to highlight how to estimate errors and uncertainties in measurements. Our objective for this lecture are the following. So to differentiate accuracy from precision and to evaluate the accuracy and precision of measurements using by estimating the errors and uncertainties of our measurement. So the flow of this lecture is will consist of concept builders. So once we got into our concept builders, you may pause this video and resume watching after you submitted your answers in the given Padlet link, and a brief discussion of the concepts. So the quality of our laboratory experiments depends on the quality of the data measured. So how successful is our laboratory experiment is similar to asking how accurate or how precise our data set is. So we will begin our discussion by defining accuracy and precision. So to do that, let us have a simple activity. So your explanation here, you can submit it in the given Padlet link. So I would like you to copy and draw this circle in your notebook. So copy as much as possible itong circle na to. And then, afterwards, kapag nakopya nyo na, I would like you to repeat it 3 more times. So draw the circles 3 more times. So by using this activity, how are you going to define and differentiate accuracy and precision? So in this context, using this simple activity, paano mo ma-define at paano mo mapagkakaiba yung accuracy from precision, accuracy and precision. So you may pause this video. Okay, so in this context, accuracy is how similar will be your drawn circle to your reference circle. So if we have here our reference, so ito yung reference natin, gaano ba kaparehas yung drawing mo doon sa reference mo? So how similar are the size, for example, or the color? So gumamit ba kayo ng red ink para i-drawing yung circle mo or black ink or other color? Yung shape. So, perfect circle din ba yung drawing mo katulad ng reference mo? So, accuracy is the measure of how similar is your drawn circle to your reference circle. So, in this context, while precision is how similar are your drawn circles to each other. So, if we have here our reference, so yung drawing mo, for example, ito yung 4 na drawing mo, with or with no respect, with or without respect to your reference circle, we can measure the precision of your drawing. So in this context, precision is how similar are your drawn circles to each other with or with no due respect to the reference, because measurements can be precise but inaccurate. Diba? So, pwedeng precise yung measurements mo, pero malayo siya dun sa reference mo. So, that's why we define precision here as the measure of how similar are your drawn circles to each other. So kung magkakapare-pareho ba yung itsura ng circles or magkakapare-pareho ba yung size ng drawing mo, yung size ng circles mo. So if not, so for example, like for example in this illustration, we can say that there is a problem in the quality of your work. So in the quality of your, or in your ability to replicate the circle. So for example, again, so layuan muna natin itong circle. So for example, you are to replicate Mona Lisa. So your ability to copy Mona Lisa to the smallest details. For example, nakuha mo ba yung mukha ni Mona Lisa, or nakuha mo ba yung environment, yung color na ginamit? Parehas ba dun sa reference mo? That is the measure of your accuracy. While your ability to replicate Mona Lisa multiple times is your level of precision. That describes your precision, yung ability mo to reproduce the same results over and over again. So the idea is the same when we put it in the context of measurement. So sabi nga natin kanina that the quality of our laboratory experiments depends on the quality of the data measured. So how successful is our laboratory experiment is similar to asking how accurate or how precise our data set is. So sabi natin dito, precision and accuracy are ways of describing the quality of your measurements. And the best quality, wait lang. Okay, so the best quality, best result natin is when your measurements are both accurate and precise. So that is the best result na gusto nating mangyari kapag tayo nagko-conduct ng experiment o kapag tayo nagme-measure ng something. So if we want to find, if we want to perform an experiment, our best result is to have an accurate, both accurate and precise result or data. So here is a comparison between accuracy and precision. So accuracy is defined as the degree of closeness. Ayan. So it is the degree of closeness or the measure of how close a measurement is to the true value. So yung true value natin dito is also called as the actual, the real, the accepted, or the theoretical value. So, gaano ba kalapit yung measured value, yung obtained value or your experimental value to the true value is the measure of accuracy. And on the other hand, yung precision naman natin, it is defined as the degree of closeness of the measurements to each other. So, it is the exactness, the consistency, or repeatability of measurement. So, precision is how similar your measurements are. So, katulad nung kanina, di ba, dun sa simple activity natin, precision is how similar are your drawn circles to each other. So, here, precision is how similar are your measurements. So, measurements, take note that measurements are precise when you measure the same item multiple times and the values are close to each other. So, however, take note din class that precision tells you nothing about the accuracy of your data set. So this means that it is possible to be very precise but not accurate. And it is also possible to be accurate without being precise because precision is independent of accuracy. So there are times na yung measurements can be close to each other but far from the true value. So that is why yung precision natin sinasabi natin that it is independent from accuracy and we cannot say that dahil precise yung measurements natin, accurate na siya. So sometimes it's true and sometimes it's not true. So that's why precision is independent of from accuracy. So for concept builder number 1, so I would like you to describe the level of the accuracy and level of precision of the following target and include also a brief explanation kung bakit yun yung description ninyo. So just use high and low. So just use high and low as your adjective for the level of precision. So high and low. So, alin dyan yung merong high accuracy, high precision, high accuracy, low precision, high precision, low accuracy, and low precision and low accuracy. And then, maglagay kayo ng explanation. Okay, so, to answer this problem, so our first target here, so kung makikita nyo, if this is a dartboard, yung mga tinamaan ng darts natin, napunta siya dun sa bullseye. So, di ba kapag analogize natin yung accuracy and precision sa isang dart or sa archer, for example, dito sa target natin, yung bullseye natin represents our target value or our actual value. So since yung measurement natin or yung dart natin, tumama siya halos lahat, nandun siya sa bullseye. So we can say that this target depicts high accuracy and high precision. Kasi yung data din natin, yan ang mga X marks natin dyan, magkakalapit sila sa isa't isa. So therefore, since close yung mga result to each other, it has high precision. And since the values or the result are found at the bullseye, then it also has high accuracy. So our second target has low accuracy. Kasi kung titignan natin, if this is our actual value, malayo yung ating result doon sa actual value. But if we look at the data set, so if we look at the results, yung result natin is close to each other. So yun na yung sinasabi natin kanina, that measurements can be very precise pero inaccurate. And sometimes, pwedeng accurate siya pero hindi siya precise. So dito, this target number 2, illustrates low accuracy pero high precision. Ito naman, we have here high accuracy pero low precision. So such as this one, yung mga result natin, yung mga, for example, this is a dart. So malapit siya sa target value natin, sa bullseye. However, kung titignan natin, malaki yung agwat nung kada result sa isa't isa. Yung isa natatagpuan dito, yung isa andito, yung isa andyan, or pwedeng meron pang ibang mga tawag dyan. Pwedeng meron pa dyang ibang mga dart sa gilid. So dito, high accuracy kasi kung titingnan natin yung mga result natin, malapit siya dun sa target natin. Pero low precision kasi magkakalayo-layo yung result natin, yung darts natin. And the last depicts low accuracy and low precision. So although meron tayo ditong malapit, pero yung iba malayo. So ayan. So kapag kinuha natin yung average niyang lahat, so malayo siya dun sa ano natin, dito sa tawag dito, sa target natin or sa actual value natin. And also the result are far from each other. So malayo yung mga result natin, yung agwat nila sa isa't isa. That's why this target illustrates low accuracy and low precision. So poor accuracy and precision leads to potential errors in measurement. So where we define error as the difference between the measured value and the true value. So there are three general types of errors in measurement. So these are blunders. We have also systematic errors and random errors. So let's start with blunders. Blunders are also known as personal errors. So these are errors caused by carelessness and accident. So that's why sometimes blunders is also called as accidental error. So sulat ko lang dito. So it is also called as accidental error or gross error or hindi kaaya-ayang error. So blunders usually result to anomalous data in your experiment. So when we say anomalous data, this is data that can extremely affect your data set during the analysis. For example, when you have to do multiple trials in an experiment that involves measuring 12 milliliter of a solution, pero nagkaroon ka ng accidental spill. So, instead of reading 12 ml, mas mababa yung nakuha mo. So, for example, you have to perform 5 trials. Doon sa first 4 trials mo, yung result mo are 12.1, 12.2, 12.0, 11.9. And then, because of an accidental spill, yung last mo na record or na measure is just 10.5 ml. So compared to this first 4 set of your measured obtained value, this is an anomalous. This can be treated as an anomalous data. So from when you have an anomalous data, this data or the anomalous data is omitted from the analysis of the result because this can affect the quality of your data set. Another example would be carelessness in recording your measurements. For example, so dito, a scale might read 21 centimeter, but because you are careless in recording your tawag dito, your measured value, you wrote down 12 cm so instead of 21. So this will of course affect the quality of your data set. The second type of errors in measurement is the systematic error. So these are errors in procedures. So meaning, so there is an error in the process of obtaining your measurements or obtaining your data. So systematic errors has an identifiable cause and you can trace it back in the procedure of your experiment. So kapag systematic error, you can trace back the cause of your errors in the procedure or in the process, in the design of your experiment. So errors of this type result in measured values that are constantly too high or constantly too low compared to the expected or true value. So that is why when you commit systematic errors or when you have systematic errors in your measured value, it resulted to a precise. So the measurements are precise but inaccurate. Yan. So parang tama naman, sinusunod mo naman yung procedure, di ba? So parang tama naman yung ginagawa mo yung nandun sa experimental design. Pero bakit pag kinumpare mo siya doon sa expected, doon sa theoretical value, bakit malayo doon sa theoretical value? Magkakalapit naman yung result mo. So if you have this type of error, you need to go back to your design. You need to go back to your procedure, experimental procedure, in order to troubleshoot this kind of error. So the sources of systematic errors can be environmental, observational, instrumental, or theoretical. And a common type of systematic error is the offset or zero error. So you commit this when you have problems with your instruments or kaya doon sa paggamit nyo ng instrument. For example of an offset error is that you use broken ruler instead of a complete ruler. So, putol yung ginamit mo. Of course, hindi ka niya mabibigyan ng mas tamang value. So, what if andito tumapat yung object? So, of course, yung gagawin mo na lang is estimate mo instead of getting the true value or getting a close value, accurate value. And another would be for the zero error is that sometimes yung mga gumagamit ng ruler or other, for example, weighing scale, yung iba hindi calibrated. So, for example, sa weighing scale, minsan yung zero, 'di ba dapat yung pointer natin before we weigh, dapat nakatapat siya sa zero. But sometimes yung pointer natin nakatapat siya or yung number dito is not zero. Minsan naka 10 or minsan nasa 105 or 100 or something. Hindi siya magbibigay ng correct measurements. The same with the ruler. So, di ba sa ruler, meron tayo dyan na markings for zero. So, kapag nagamit ka ng ruler, dyan mo itatapat yung edge ng mini-measure mo. But others, yung hindi marunong gumamit ng ruler, ang ginagawa nila, tinatapat nila dito sa dulo. So this area here will give you an error in your measurement. So which implies that you are already few millimeters away from the true measurement of the length of your object being measured. So instead of getting 9 for example, since dito ka nagsimula, so magiging na lang siya for example 8. So mali na yung na-record mo, mali na yung measured data mo. And the last type of errors in measurement is the random error. So random errors are naturally occurring errors. So these are errors due to unavoidable environmental conditions. So most of the time, the sources of this error cannot always be identified. So since the error happens at a random, it becomes difficult to trace the cause of error, unlike in the systematic error where you can always examine the experimental procedure or the design in order to troubleshoot your error in measurement. Sa random errors, mas mahirap siya kasi hindi mo alam kung kailan ka nagkamali, kung saan ka nagkamali, o kung sino yung nagkamali, kung grupo kayo, di ba, na nagko-conduct ng experiment or gumagawa ng nagkukuha ng measurement. So, mahirap hanapin kung sino nagkamali or kung saan kayo nagkamali. So, when you commit this type of error, kapag random error ang meron kayo, your measurements are imprecise. So, this affects precision of your measurement. So again, kapag systematic error, yung ano nyo, yung measurement nyo is precise but inaccurate. Pero kapag random errors, it affects the precision. So hindi ibig sabihin na accurate. So some of your data may be accurate, but some of your data may be inaccurate. And yung kalahatan ng data mo is not precise kasi random yung error na nangyayari. So this will result to a wide difference in your set of data, variation in data. So the sources of systematic errors can be environmental or observational. So one type of random error is the reading error, so which cause is observational. So sa reading error, di ba? For example, itong dalawa. So, for example, siya yung isang nagko-conduct ng gagawa ng measurement, siya din yung isa pang gumawa ng trial 2. So, dun sa isa, yung estimate niya is 4, pero yung isa, yung estimate niya is 3. So, this is already an example of observational cause ng random errors. So, reading error is an error that arises when we do direct measurement of some quantity. So, for example, you are going to measure the length of this wood. For example, kahoy siya. And then gumamit ka ng ruler. So ito yung edge niya, di ba? So 3D for example. So ito yung edge niya and then this one is the edge. So andito yung 0. So there are times na yung edge ng object na mini-measure mo, hindi siya tumatapat sa linya. So minsan nasa kalagitnaan siya. So you need to estimate kung saan siya mas malapit. So, for example, if this is 11 and this is 10, so sino ba siya? Mas malapit ba siya sa 11 or mas malapit ba siya sa 10? So in this case, how well would you be able to provide the estimate? So you need to learn how to provide the estimates when measuring a data because this will lead to a random error. So accuracy is the measure of how small is the systematic error of an experiment. So the smaller the systematic errors, the more accurate are your measurements. While precision is the measure of how small is the random error of an experiment. So the lesser the variation in data, the smaller are the random errors. Thus, the more precise are your measurements. So how do we now evaluate the accuracy and precision of your measurements? So recall that accuracy is the correctness of your measured value in comparison to the true value, while precision is the consistency of your measured values or how similar are your measured values or experimental values to each other. So in evaluating the accuracy, we need to solve for the error in our measurements. And by solving for the error, solving for the error allows us also to evaluate the precision of the measured values. So measurement error is the difference between a measured quantity and its true value. So it is the measure of how far away is your obtained measurement from the true or actual value of the measurement. So there are different ways on estimating errors or for solving for the errors in our measurement. So we can solve for the absolute error, percent error, percent difference, and we can also look for the mean variance and standard deviation in order to estimate the errors in our measurements. So let us first define each of the following. So absolute error or delta E is the difference between your obtained or experimental measurement and accepted measurement. So here is our formula for the absolute error. So, yung absolute error natin is the absolute of the difference between the experimental value or yung value na ikaw mismo yung nag-measure and the true value or the accepted value. So, kapag tinanggal natin yung absolute, it is simply the error. So, yung error naman, for example, yung error natin is the experimental value minus the accepted value. So yung error natin can be positive or negative. And this sign symbolizes, denotes whether yung obtained value mo is larger than the true value or yung obtained value mo is lower than the true value. So later, we will have an example to differentiate error and absolute error. So absolute error is the measure of how far is your obtained measurement to the accepted value. So when solving for the absolute error, you are measuring the actual size or the actual difference between your obtained and true value. So if we have here 12, for example, 12 is our um, accepted value or true value, and then meron tayong measured na 13. So yung absolute error simply just tells you ano ba yung agwat between these two. So dito isa lang naman, di ba? So what is the absolute error? So ang absolute error will always be positive because of this absolute sign here. So next we have percent error. So percent error is the absolute error divided by the accepted value multiplied by 100. So here is our formula. So percent error is equal to the absolute error. So kung makikita nyo to, this is just this one. So absolute error. So kung binigay na yung value ni absolute error, then no need to solve for the absolute error. Pero kung hindi binigay, you can look for the absolute error before solving for the percent error. So this equation above is simply the formula for the absolute error. So percent error is the absolute error divided by the accepted value times 100. So here we are relating the error to our true value. So hinahanap natin kung gaano ba kalaki itong si error na to, yung value ni error compared to our true value. So again, yung x sub b is your experimental or obtained value, and x sub a is the accepted or expected value or the theoretical value. So percent error measures how large is the error committed compared to the true value. So isulat ko dito, it measures how large is the error. The error compared to the true value. So that is the percent error. So it measures how big of a part is your error relative to the true value. And it tells you how big is the error of your measurements, or how close is your measurement or your experimental value to the true value. So percent difference or percentage difference is the difference between two measurements divided by the average of the two measurements multiplied by 100. So here we have here x sub 1 and x sub 2, wherein x sub 1 is the first experimental value and x sub 2 is the second experimental value. So these x sub 1 and x sub 2 here are experimental values. And then, to get the percent difference, sabi dito, we get the absolute of the difference between two experimental values divided by their average times 100. So, percent difference compares experimental values to find out how much these values differ from each other. So, it tells you how large or small is your obtained data from other values in your data set. So percent difference, since it compares your obtained value from other obtained value, percent difference indicates precision. Yeah, so it indicates precision of measurement since it takes all the experimental values and compare them to each other. So again, kapag sinabi natin percent difference, it tells you how large or small is your experimental value compared to other experimental value. That is for the percent difference. So let us have an example. So here, so 3 trials were performed to determine the distance rather, between building A and building B. So the first group measured it to be 503.5 meters. The second group measured it to be 502.8 meters, while the third group measured it to be 497.4 meters. So if the actual distance between building A and building B is 500 meters, so determine A, the absolute error of the measurements, B, the percent error of the measurements, and C, so nakalimutan ko. So C, percent difference between two measurements. So let's answer letter A. So ang hinahanap natin dito, we would like to find the absolute error of the measurement. So to look for the absolute error, we simply use this equation. So absolute error, or delta E, is equal to the absolute of the difference between the expected and the accepted value. So mas madaling hanapin or mas madaling ma-analyze ang data, especially kung madami kayong numbers and or data set. Mas madali siya kung gagawin nating tabular form or in tabular presentation. So here, we have here 3 trials conducted by group 1, group 2, and group number 3. And here are our experimental values. So here, ito ang x of 1, itong value na to. This is our x of 2, this is our x of 3. So yan. So 503.5, 502.8, and 497.4. So first, we need to look for the error. So yan muna sa loob. Diba? Yung error natin, para makuha yung error, kanina diba nabanggit ko na yung error, is equal to the experimental value minus the accepted value. So ito, sabi natin, error can be positive or negative. So dito, yung error natin sa unahan is positive 3.5, dito positive 2.8, and dito negative 2.6. So anong ibig sabihin ng positive and negative? So this means kapag positive yung error mo, ibig sabihin itong experimental value mo is larger than your true value. So nakikita naman natin that 503.5 is larger than 500 meters. So larger by what number? So it is larger by 3.5 meter. So 502.8 is larger than 500 meters by 2.8 meters. So mas malaki siya ng 2.8 meters. While 497.4 is smaller than 500. So smaller siya ng 2.6 meters. So to get the absolute error, just simply get the absolute of this one. So kapag kinuha mo yung absolute, of course, you will get the absolute error. So again, the positive and negative sign denotes the experimental value is higher than or lower than the actual value by the measure of error. So absolute error measures the number of deviations from the actual value but will not tell you whether your obtained value is smaller or larger. So dito, kapag kinuha mo yung absolute error or kapag given ng absolute error, hindi mo makikita kung whether this error tells you na yung obtained value mo ba is larger than the actual value or smaller than the actual value, kasi wala siyang signage dito. Pero kung meron siyang signage, you can tell whether mas malaki yung experimental dun sa actual value. Okay, so now that we have the percent error or the absolute error, we can now look for the percent error. So again, percent error is equal to the absolute value or absolute error divided by the accepted value times 100. So you just plug in this value, substitute it to the equation. So wherein ang accepted value natin is equal to 500 meters. So if we plug all these values to this equation, so makukuha natin na Yung number 1, x of 1, which is 503.5 meters with an error of 3.5 meters. So, absolute error of 3.5 meters. Yung percent niya, 3.5 meters is 0.7% of 500. So 2.8 meters, itong error na to is 0.56% of 500. So 2.6 meters naman is 0.52% of 500. So the percent error um about tell us how big is the error compared to the true values. For example, si 3.5 is 0.7% of 500. So solving for the percent error will immediately give us a hint on whether we need to worry or not about the errors in our data. So kailan ba tayo dapat mag-alala kapag nakita na natin tong mga percent na to, di ba? Malaki ba siya or mababa ba yung error natin? So let us look at the following example. So I have here, so in this situation, so the absolute errors of the two, ito yung isa. So the absolute errors in the two measurements are the same. So yung absolute error natin sa situation to, sa situation 1 is 3.5, dito din 3.5. Okay, so excuse me lang. So yan, so kung titignan natin, dito, yung accepted value sa situation number 1 natin, ito yung situation 1 and this is situation number 2. Yung accepted value sa situation 1 natin is larger compared to situation 2. So in these situations, when can we say that 3.5 error, so an error of 3.5 is a big error or not? 'Di ba? So, titignan natin dito. So malaki ba yung kapag nagkaroon ka ba ng 3.5 na error or absolute error, malaki ba yung error na to or not? So you need to solve for the percent error. So yung percent error natin, again, by using the formula and then substituting the value. So dito, given na yung absolute error, so no need for this one. So just change in E over X of A times 100. So 3.5 divided by 500 times 100 is 0.7%. Sa kabila naman sa situation 2, 3.5 divided by 20. So kung makikita natin dito, 20 lang yung accepted value natin. 3.5 divided by 20 times 100 is equal to 17.5%. So kung makikita natin dito, ito meron siyang 17.5% na error compared dito na 0.7%. So sabi natin, di ba? So take note that percent error tells us how big is the error in our measurement relative to the true value. So, diba? So, yung 3.5, pwedeng maliit siya na error kapag ang true value mo is 500 or larger. Pero pag ang true value mo is smaller, yung 3.5 becomes a big part of your true value. So, nagiging siyang mas malaking error. So, yun yung binibigay sa atin kapag nag-solve tayo ng percent error. So for letter C, so solving for the percent difference of any two measurements, so ang kinuha ko dito is measurement 1 and then measurement number 2. So pwede rin naman na mag-solve kayo between, for example, x1 and then x3. So between these two, or pwede rin x2 and then x3. So any, between any two obtained measurements or experimental values in your data set. So again, this is our ang tawag dito, formula for percent difference. So ang kinuha ko dito is yung x1 and then x of 2, wherein ito yung obtained values natin kanina. So by substituting it to our equation, so yan yung makukuha natin na value. So how big is the difference between the first and the second measurement? So there is a 1391% difference between the first and second measurement, or about 0.14%. Like if we round this up to two decimal places, So the difference between the two measurements is 0.14%. So this tells us that that 503.5 is 0.14% bigger than 502. So for example dito, meron tayo ditong two values, di ba? So mas malaki si x sub 1 kay x sub 2. So pwedeng ang statement natin dito is that 503 or x sub 1 na lang is 0.14% bigger than or larger than x of 2. Or pwede rin na x of 2 is 0.14 smaller than x of 1. And you can also compare others. For example, may x of 3 tayo. You can also compare it to any of these experimental values. So take note, percent difference is tells you how large or how small is an experimental value compared to other experimental value. That's why it is a measure of precision. So let us have a concept builder. So you may pause this video and then resume watching after you submitted your answers in the given Padlet link. So problem number 1. So a dense object is dropped a distance of 100 meters and the acceleration of the object is found to be 10.2 meters per second squared. So if the acceleration of a falling object is said to have the acceleration due to gravity, which is 9.8 meter per second squared, how large is your measured acceleration compared to the acceleration due to gravity? And dagdag ko na rin dito, how large is your error? Ayan. How large is your error? So number 2, so two trials were performed in an experiment to determine the latent heat of vaporization, Ls of V, of water at 100 degrees Celsius. So the values of the latent heat of vaporization of water obtained were 532 calories per gram and 536 calories per gram. So find the percent difference between the two values. So you would like to know how much larger or smaller are these two values compared to each other. Okay, so you may pause this video and just resume watching afterwards. So to answer number 1, so we were asked how large is our measured acceleration compared to the acceleration due to gravity. So yung measured acceleration natin is 10.2 meter per second squared. So gaano kalaki yung 10.2 meter per second squared compared sa 9.8 meter per second squared. So 10.2 meter per second squared is 0.4 meter per second squared larger than 9.8 meter per second squared. So this is our absolute error. It just tells us the difference between the two values. So between the experimental and the absolute values. So how large naman is the error? So if this is our error, how large is this error compared to our true value? So to answer that question, we need to solve for the percent error. So here, so using this equation, substitute with the given, and we'll get a value of 4.1%. So 0.4% or 0.4% or 0.4 meter per second squared is 4.1% of 9.8 meter per second squared. So this is how large is our error, 4.1% of the true value. Okay, so to answer number 2, so we would like to know, we would like to compare two latent heat of vaporization of water. So using percent difference, ayan, so yun yung equation natin, substitute lang natin. So we'll get this value. So the percent difference between these measured values is about 0.749 or 0.75%. So meaning 536 is 536 is 0.75% bigger than 532 calories per gram, or 532 calories per gram is 0.75% smaller than 536, or lesser than 536. What if there are multiple experimental values ay, in our measurements? So how do we solve for the accuracy of your data? So in this case, we solve for the mean of the data and then compare it to the actual value. So if we have a data set or multiple values, we get the mean and then compare this mean to your actual value. Say for example, we have two data sets here. So set A and set B, and that the true value is 10 inches. So how do we now solve for the accuracy? So sabi natin kanina, we need to solve for the mean. We need to get the mean in order to compare it to our actual values. So by the way, we can also compare this individually, but if we want to know whether your set of data is accurate or not, we need to solve for the mean. So we need to solve for the mean of set A and the mean of data set B. So we don't know yet that these values. So to solve for the mean, the formula is mean is equal to the summation of x, where x is our individual observation. So we have here 5 observations. So we get the sum of these 5 observations and then divide it by the number of observations. So n here, so ang n natin dito is equal to the number of observations. So we have here 1, 2, 3, 4, 5 observations for both set A and set B. So ang n natin is equal to 5. So if we get the sum of set A and then divided by 5, then we'll get this value. So the mean of data set A is equal to 10.02 inches, while for the mean of set B is equal to 8.08 inches. So just by looking at these values, just by looking at the mean, so we can already infer that set A is more accurate compared to set B. Kasi meron tayo na ditong actual value basis to see whether a data set is accurate or not. So just by looking at the mean and comparing it to our actual value here, so makita natin na mas malapit si 10.02 sa 10 inches compared to 8.08 inches. So that's why dito pa lang pwede natin sabihin that set A is more accurate. But if you want to quantitatively describe the accuracy of your data set, you need to solve for the error of your measurement. So you can solve for the absolute error or you can solve for the percent error. So in this case, let's just use the percent error in order to relate our absolute error, to relate our error to the actual value. So percent error, again, di ba? Sabi natin, it is equal to the absolute error divided by the actual value times 100. So yung absolute error natin dito is solved through this equation. So, di ba, absolute value is equal to the absolute of experimental value minus accepted value. So, yung experimental value natin dito is not an individual value. It is a set of experimental value. So, yung ilalagay natin dito, instead of x sub e, pwede natin ilagay dito is yung mean ng ating observation. So, yung mean minus the accepted value times 100. So, kung ilalagay natin dito, i-substitute natin yung mga value sa percent error ng dataset A natin is equal to the mean of dataset A minus the actual value. So, baka malito kayo dito. So, ito, mean to ng dataset A. Ito yung accepted value natin. Divided by the actual value times 100. So, kung i-substitute natin yung value, we have here 10.02 minus 10 divided by 10 and then times 100. So, makukuha natin dito, so erase ko lang to. So, yung percent error ni dataset A natin is equal to 0.2%, while the percent error of dataset B is equal to 19.2%. So, if you substitute again the values coming from dataset B doon sa ating equation, sa formula ng percent error, ito yung makukuha natin. So, isulat ko ulit dito yung mean of A, which is equal to 10.02 inches, and mean of B, which is equal to 8.08 inches. So, kanina, we claimed that just by inspecting the mean and comparing it to the actual value, di ba nakapag-infer tayo that set A is more accurate compared to set B. Pero to support your claim, you need a value to support your claims. You need to solve for the error of your data set. So, yung error ng dataset A is 0.2%, yung error ni dataset B is 19.2%. So, kapag mas mababa yung percent error, mas mababa yung error na nakuha mo sa calculation, ibig sabihin, mas accurate yung data. So, tama yung assumption natin kanina that dataset A is more accurate than dataset B kasi mas mababa yung percent error niya. So, just 0.2 compared to 19.2%. So, paano naman kapag unknown yung actual value? So, how do we estimate the error? So, first, kapag unknown yung actual value and then kailangan nating mag-measure, we need to do multiple trials in order to collect a set of data. So, in this manner, we would be able to minimize the error in our measurement. So, pwede natin siyang gamitin, yung set of data, in order to look for the most probable value that could represent your data, and that most probable value could be the value of your true value. So when we don't know the true value, we consider the mean of the set of data, the set of measurements as the most probable value. So closest to the true value. So kinukuha natin yung mean because we consider the mean as the most probable value. Meaning, so this is the value that is closest to the true value given a set of data. Pero sabi natin, di ba, yung precision is independent of accuracy. But although this is the case, we settle on how precise are the obtained values in order to accept that the set of values can be used to provide a correct measure. So kapag, di ba, sa actual na pag-experiment natin, so di ba, sa most of the time, or there are times na wala naman tayong basis sa measurement natin, wala tayong standard or wala tayong actual values to compare our measurement. So in this case, nagbe-base na lang tayo sa accuracy ay sa precision ng ating result and hope that these values can be can represent the true value or can be used to find the true value. Pero kapag ginawa mo to, you need to include also uncertainty. So that's why when the value is when the actual value is unknown, we can solve for the mean, variance, and standard deviation, and we need to include the uncertainties in your measurements. So again, mean is the average of the observed value. So this is considered as the most probable value or just MPV. Yeah, most probable value. So meaning, it is considered as the most probable value or the value closest to the true value. So to solve for the mean, we use this formula. So x bar is equal to the summation of x, where x is our individual observation. So we need to get the sum of your individual observation, then divide it by the number of observation. So next is the variance. So variance measures variability from the average or mean. So it is calculated by taking the summation of the squared difference between measurement and the mean. So itong nasa loob ng parenthesis na to, this is also called as the mean deviation. So meaning, gaano ba kalaki or kaliit or gaano ba kalayo yung individual measurement mo sa mean of your data set. So ito, this is the mean deviation and this is our squared of mean deviation. So kapag tinanggal natin, kapag nilagyan na natin to, squared of mean deviation. So therefore, we need to get the squared of mean deviation and then we need to get the sum of this squared mean deviation divided by the number of observation in order for us to get the value of our variance. So variance is the overall spread of data, of your data. Next is the standard deviation. The standard deviation is the square root of variance. So if the variance is already given, in order to get the standard deviation, you just need to get the square root of the variance. If not, you can proceed with this method. So yan, i-substitute nyo na lang yung nasa equation. So it is a measure of how diverse or spread out are the measurements from their average. So standard deviation, ito yung equation natin. Again, so sigma is the standard deviation, x of y is the measurement of the ith experimental value or the individual measurement, and then x bar is the mean or the average, and n is the number of observations. So variance and standard deviation is the measure. So it's the measure of how scattered are your data set. So variance, since that is the case, it is variance and standard deviations are indicators of precision. So it measures how far away the numbers from the average and how far away from each other are the measurements within a data set. So a variance of 0, kapag ang variance daw natin is 0, meaning identical yung mga values natin, yung mga measured values. For example, nag-measure ka ng 12 centimeter. Kung 0 ang variance, ibig sabihin yung other measurements mo must be 12 centimeter also. Yan. So kapag ang variance is equal to 0. Larger variance means mas widely spread, mas scattered yung data. And if you have small variance, it indicates that the values are close to one another, which means they are precise. So ibig sabihin, mas mababa yung variability or pagkakaiba-iba ng mga measurement mo or ng data set mo, which means mas precise yung mga nakuha mong values. On the other hand, a small standard deviation means that most of the measurements are close to their average, and a large standard deviation means that the measurements are very diverse and they must be far away or farther from the mean of your data set. So if we have here the mean, if we have given a number line and this is the mean, so kapag mababa yung standard deviation mo, ito diba yung kapag standard deviation, ito yan. So for example, 1 standard deviation, ito is 2 standard deviation away, ito yung measurement natin. Kapag 1 ang standard deviation mo, yan yung agwat ng kada, kung meron tayong number line, yan yung kaagwat or resolution ng number line mo. Yung increment ng number line mo. So 1, 2. So this is 2 standard deviations away. This is 1 standard deviation away. So yan, 1. Kapag mas mababa yung standard deviation mo, for example, 0.5 lang. So 1 standard deviation away. So ito, 0.5 lang yan. So 2 standard deviation away. So ibig sabihin, another 0.5. So compared dito, di ba, sa taas natin, we have here, itong 2 standard deviation away is already 2. Yan. Ito, 1 lang, although 2 standard deviation away. So just recall your statistics. So although standard deviation is an indicator of precision, standard deviation can also be used as an expression of our error in measurement. So nagagamit natin yung standard deviation to express the errors in measurement. So therefore, it can be used to identify the accuracy of your measured value. So paano yun nangyayari? So let's see how measurements is reported. So in reporting the measurement X of a physical quantity when given a set of data, we use this expression. So X is our measurement and X bar is the mean, so plus or minus the standard deviation. So this expression indicates that the best estimate of the true value is found between the mean plus or minus the standard deviation. So for example, ang mean natin is equal to 10, tapos ang standard deviation natin is equal to 0.5. So ang ibig sabihin nito, that the true value lies between, so dito, X minus or mean minus standard deviation to mean plus standard deviation. So 10 minus 0.5 is 9.5, and then 10 plus 0.5 is 10.5. So meaning that the true value or your actual value is found within from 9.5, between 9.5 to 10.5. So yun yung ibig sabihin natin dito. So your measurement is accurate as long as it falls within the range of values where the true value lies, or it is more accurate if it is closer to this range of value. So if you, for example, if you measure a physical quantity, the same physical quantity, tapos nag-equal siya sa 11, so given that the range is only from 9.5 to 10.5, so 11 is a not so accurate value. Pero malapit siya doon. So pwedeng mataas din ang accuracy niya, pero hindi siya super accurate. Kasi andito yung most probable values natin is found within this range of values. So let us have a concept builder. So you may pause this video and just resume watching after you submitted your answer. So problem solving. So the following values were determined in a series of tape measurements of a line. So 1000.58, 1000.40, 1000.38, 1000.40, and 1000.46 meters. So determine the following. So A, variance of the measurements, B, standard deviation, and C, the measure of the line. So isabay na rin natin dito yung mean of your data set. So let's answer this problem. So in solving a problem involving a set of data, it is easier to present it in tabular form. So we have here our individual measurements, X. So X of 1, X of 2, X of 3, X of 4, and X of 5. So therefore, ang number of observation natin is 5. So first, let's look for the mean of our, what do we call this? Of our data set. So again, to get the mean, so we use this formula. So i-add lang natin lahat ng observation and divide it by the number of observation. Therefore, yung mean natin is 1000.44. So ito yung mean na natin at sulat na natin dyan. And then, we need to solve. So para makuha natin si variance and standard deviation, we need to solve for the mean deviation. So to get that, we need to subtract our mean from our individual observation. So 1000.58 minus 1000.44 will give us 0.14, and repeating the procedure, these are the gathered data. So result natin from solving for the mean deviation. So 0.14, negative 0.04, negative 0.06, negative 0.04, and 0.02. And then solve for the squared mean deviation. So square nyo lang tong mga values na to para makuha nyo itong mga, asan na yun? Ba't nawala? Wait lang. Okay, so to get the squared mean deviation, just simply square these values. Itong mga value natin dito. Ayan, so 0.14 squared is equal to 0.0196 and so on. So if you recall, the formula for getting the variance is equal to the is equal to the summation of the squared mean deviation. So, x minus x bar. Na-erase pala yung ano dito. Squared of mean deviation divided by the number of observations. So, therefore, we need to get the sum of this squared mean deviation and then divide it by 5. So, ang result natin dyan will be, ayan, so ayan pala yung equation natin. So, yung result natin dyan will be 0.00536. So, that is our variance. And then, yung standard deviation naman natin, so yung standard deviation natin is just the square root of variance. So, we have here 0.0732. So, yun yung standard deviation natin. So, yan yung complete table natin. So, how do we now report this measurement? So, yung mean natin is equal to 1,000.44. So, this is our most probable value. So, the central value that represents the data set. So, this is our most probable value, or it could be our true value. And then, we have an uncertainty. So, yung standard deviation natin, it gives us the uncertainty in our measurement. So, yan yung doubt natin. Kasi hindi tayo sure kung 1,000.44 ba is the true value. So, meron tayong doubt. So, therefore, we need to express that doubt in order to express the error in our estimate the error in our measurement. So yung uncertainty natin is our standard deviation. So yung standard deviation natin dito is 0.07. So the standard deviation is the expression of our error. Since we do not know the actual value, we suppose that the mean is the most probable value, but since there is a doubt in our mean, we include the measure of uncertainty, which is the standard deviation. So therefore, the true value lies between 1,000.44 plus or minus 0.077 meter. So take note class, yung uncertainty natin, in-express lang siya as a single significant digit. So ayan, yung sa uncertainty. So, kanina di ba meron tayo, yung nakuha natin is 0.0732. So, we need to round this to a single significant digit number. That is for the uncertainty. However, for example, kung 0.01, yan, kailangan mong idagdag yung susunod na number. So, here, so we can say, so 1,000.44 minus 0.707. So we have here 1,000.37 and then 1,000.44 plus 0.07 equals 1,000.51. So meaning the true value is found within this range of values. So pwedeng yung true value natin is 1,000.37, 1,000.38 up to 1,000.51. So that is how we report our measurement together with its uncertainty.